It's taking, there we go. All right, so we are live. So where does weight go when you exercise and we lose weight? All right, this is actually kind of a cool one. Um, we're gonna come back to this and answer it at the end. So I've seen things like weight can sometimes turn into sweat. It's condensed through your skin. I see it goes into your muscles. That's a good guess because you lose weight from your stomach, but you might get stronger and it might go in your muscles. Um, Muscle actually weighs more than fat. So if you think about that, muscle weighs more than fat. So there's something called a body mass index. If you take like a professional athlete that's very muscular, they will actually have a worse score on the body mass index than an average person because their muscles weigh more than fat does. So muscle actually weighs more, right? So I'm seeing let's see, one is sweat. All right. I see a few people have said the carbon dioxide turns into energy. All right, I like what I see. So those are all good guesses. We're going to come back around to that. But the main takeaway from this is that we're going to be talking about something called the law of conservation. And the law of conservation says that energy is conserved across a chemical reaction. All right. So I'm going to be performing a chemical reaction via nearpod. Your grade for this is going to be based off of you just completing what is in front of you. Okay. So if I ask you a question to type it out, type it out. There's going to be an exit ticket at the end as well. Okay. So this should be pretty simple and straightforward. And we're going to practice it some more tomorrow before we get out of here. So we got about 20 minutes already. So here in this beaker is vinegar. All right, this is vinegar, also called acetic acid, in a beaker, and I'm weighing it on a scale. You can see that the weight is right here. All right, it is 23.8 grams. 23.8 grams. All right, then next, I'm going to weigh out a beaker with baking soda in it. All right. So what I did was I weighed this beaker. I don't have 77.7 grams of baking soda in there, but there is it's everything in here. It's the cork, it's the balloon, it's the glass beaker, and it's the baking soda. All of those things together. Because what the law of conservation of mass says is that matter cannot be created or destroyed. So when you do like a chemical reaction, you don't magically lose matter, and matter isn't just magically created. So all the stuff you start a reaction with, you have to end a reaction with. All right. So what we should see here is that be true. All right. So that's why I'm showing you the masses. All right. So let's do some math. If the vinegar weighed 23.8 and the beaker weighs 77.7, what should the total mass be? Show your work. So I'm going to give you guys a few seconds to give this a try. Remember, this part is one of the things that's for grade. What is the total mass of this reaction? All right. Looking good so far, guys. I'm seeing a lot of you guys set it up correctly. Devin, good job. All right. Aaliyah, good job. Janae, good job. Aaron, you're good. Shanella, you got it set up right, but check your math. Jasmine, good. All right, make sure you guys hit the submit button down at the bottom. Kennedy, good. Autumn, good. All right. Again, I see a lot of you guys have it set like are I can see that you guys are typing and writing, but make sure you guys hit the submit button when you're done. All right. So to find the total mass, what you do is you add it. All right. So it's an easy answer, and I chose this one because it's easy to see. All right. So 23.8 plus 77.7 equals 101.5. So
Mr. Pescatress,
yes.
I couldn't even finish my answer.
What took so long?
I was still doing my math. Dang, Mr. Pescatress, I'm trying to make sure I get it right.
Yeah, I had trouble with writing it.
Okay. So one thing you guys could do next time around is let me see here. Is this text box here? You can type your stuff in. So you could do 23.8 plus equals, and then type your answer out. That,
Yeah,
um, or I just use my finger.
that's what I was using my finger. That's why it took so long.
Okay. All right. So here we go, and let's move it on. All right. So predict. What do you think will happen to the mass reaction once the chemicals are mixed? So once we mix these chemicals together, what do you think is going to happen to the mass of the reaction? So right now, I'm going to mix the vinegar in with the baking soda. So I'm going to mix those two things together. The mass of the reaction before is 101.5. What's the mass going to be after they react? Now you don't have to like give me a specific number, but just do you think it's going to go up? Do you think it's going to go down? What do you think is going to happen? All right, so just give me like a quit thing. All right, you guys in about 10 seconds. Again, I just need like one sentence. All right, so I'm seeing a lot of a little bit of a mix, like split right down the middle. Is it going to increase or decrease? It's kind of split down the middle. I'm seeing some people saying it's going to increase because there's going to be gas produced, and I'm seeing some people saying decrease because you're going to create something new. So it's good. All right, moving on. All right, so defend your prediction. So a lot of you guys have already said something like this, so just be quick on this one. So why do you think it's going to go up or down or stay the same? What do you think? All right, so just give me like a one sentence. So it's like I think blank because blank, something like that. All right, Autumn and Jasmine, thank you. Good job. All right. So remember that even if you're guessing, your guess is based in a hunch that's anchored somewhere in your mind. All right. So a guess is still based on something, even if you don't think it is. All right. Let's go ahead and hit that, smash that submit button. 'Cause I want to move on. I just want to make sure you guys get your answers in. Okay. All right. Good. So let's watch. All right. So here is it before the reaction. There is the vinegar in the beaker. All right. We did the math. So beaker with the baking soda, 77.7. Vinegar is 25 milliliters, which is 23.8 grams. Altogether, like you said, is 101.5. All right. So the mass is going to change on the beaker because I have to do the reaction off the beaker. All right. So you see the reaction taking place. You're seeing bubbles being formed, gas being produced. The balloon is inflating. And look at the reading on the scale. Boom. Just like you predicted. Okay? Pretty cool. All right. So
So it
the
went up.
the mass didn't change. All right. So you guys remember we did that math that it came out to 101.5. So after we mixed the stuff together, it still was 101.5. Okay. So pretty neat that this is the law of conservation of mass, is that matter cannot be created or destroyed in a chemical reaction. So the mass that you started a chemical reaction with, even though it's transformed into new things, is still the same. All right. So it's the mass before a reaction is the same as the mass after reaction. All right. We're going to skip this one. All right. So how can this be? How can this translate into the warm up about the first question about um, what we did with the weight question? What do you think? So how does this compare? So losing weight is a chemical reaction. If you do a workout, feel your stomach, okay? So right now, for if you're just sitting there, it's probably feeling warm, okay? So nothing's really happening. But if you do a workout or you run up and down some stairs and you feel your stomach, it's gonna feel cold. And like we talked about before, when energy is sucked into a chemical reaction, like the breaking down of fat into energy, you are doing a chemical reaction. So your stomach will feel cold. Anytime you work out or run, your stomach you might feel very hot, but your stomach's going to feel cold because that's where you're doing a lot of the burning is right there around your stomach. So that's a good indication that a chemical reaction is happening. So where is that weight going? All right, because if it's originally in your body, where is it going? That's the big question. So take a stab at it. All right. So I see some people saying like, yeah, they did demonstrate the law of conservation of mass. They do, but we're trying to figure out how. All right. About 10 seconds to submit your answer because I do want to play a video that has the answer to it before I show you the exit ticket. All right. All right. That's annoying. Why aren't you playing audio? All right. Well, honestly, it's probably something in my settings. But it's kind of close. Let me see here. All right. It's kind of close to being the end of class, so I need to kind of wrap it up. But basically, what it comes down to is the majority of the weight you lose is 20% water, but the majority of it is carbon dioxide. So that's why you breathe really heavy when when you exercise, is because most of it is turned into carbon dioxide, which you let out, which is why you breathe heavy when you exercise. So that's kind of the end of it. All right. So sorry that didn't work out as well as I wanted it to, but we're kind of short on time. All right. So last thing to do here is this exit ticket that should have popped up on your screen. And then that's it. So knock out this exit ticket, and then I will see you later. But let me put it in the chat real quick, just in case it goes away. All right. So this is the exit ticket. And let me go ahead and post this online too, just in case when I close. I don't want you guys to lose it. Yeah, I'm still getting used to how this works in my time. So I apologize for kind of things running a little bit long today. Um, So, right. I also posted this in Schoology. So it should say Law of Conservation exit ticket for today. All right, I don't want to hold you guys up. I want you guys to be on time to your next class, so you are free to go. Thank you guys for coming today, and I will see you tomorrow at the same time.